And there's a bit for you to read there, but I'll just get straight in and we'll go through the example. So a proportion is just a part of a population that has some property or quality. So rather than we're talking about mean, mean observations, we're talking about the proportion of a population that has some property. So in our example here, we have a sample of 10 people finds that 3 of them have blue eyes. Part A, state the observed value of P hat. So there's a difference here, just like how we have X bar and mu. X bar is the sample mean, mu is the population mean. We have P hat is the sample mean, and P is the population proportion. Okay, the sample proportion, the population proportion. All right, so our sample proportion is 3 on 10 or 0.3. All right, so based off of the sample, 30% of people have blue eyes. Okay, part B, find the mean and standard deviation of P hat. Okay, so this is our second sentence here. Given a population proportion P and sample size N, the sample proportion P hat has a mean of P and a standard deviation of this one here. Now, when we're not given the population proportion, we do use the sample proportion. So the mean is equal to P, which is 0.3, and the standard deviation is, and we've got that formula there, the square root of P times 1 take P on top of N. So that's P times Q, Q being the inverse event. So you've got blue eyes or you don't have blue eyes. So in this circumstance, the square root of 0.3 times 0.7 on top of 10. So evaluate that there. .3 times 0.7 divided by 10 square rooted 0.1449 Cool. All right, part C. Is P hat normally distributed? So this is where we can talk about if we can apply the central limit theorem or not. For P hat to be normally distributed, we have to satisfy 2 properties. The first is that N times P has to be greater than or equal to 5, and N times Q, that is N times the inverse event, has to be greater than or equal to 5 as well. So if we do N times P, so we have 10 times 0.3, we're going to get 3. Okay, 3 is not larger than or equal to 5. And I'll show you the inverse event as well. So 0.3, the inverse event is going to be 0.7. They add to 1, right? So it satisfies the second one, but it doesn't satisfy the first one. For it to be normally distributed, it must satisfy both. So the answer is no, it cannot be approximately normally distributed because N times P is not larger than 5. Very good. Okay, so that's 9E. Let's have a look through that exercise and do some of that.